is John Black, Super Chemist. We're here to make some methylbenzene, most commonly known as toluene. I have some toluic acid here, about 15 grams. Got calcium oxide here. I don't know if you can see it. That's about 16 grams. And then I got 22 grams of sodium hydroxide. I'm just going to put them in this bag and mix it up a little bit. I'm not going to crush it. I mean, you should probably put this in a, mortar and pestle and, grind it all up. My way of thinking is this. This sodium hydroxide is probably 10% water, right? It's probably the monohydrate. When I heat it, it's going to melt, okay? Even if it isn't, sodium hydroxide will probably melt before the decarboxylation even occurs, right? So, if everything's wet, who cares if it's smashed up? I got it all put together, nice and uniform. You can see how it's, now that was crude. Now I put it into here, into this can. You see the can on the top. I took the thing off, or whatever, the notch that was on there, the lip. And you can see I just have an elbow. I mean, you could have any glass joint or whatever. And I put some Teflon tape, plumber's tape, on there. See that white part? Now I'm just going to screw this in. I made sure that the tape was a lot bigger than the hole. I screw it just like you'd screw a screw into a whatever. Try to keep it nice and straight. And then I'm going to hope to God that worked. Alright, here's my setup. Just a basic distillation coming out of the can. Let's hope this don't blow up. You do need a lot of heat though. Oh shit. Oh, see it coming over? Oh crap. Okay, that's too fast. I'm going to try to keep it down so that I can just distill it instead of it coming over too fast. You see, I put an ice pack on that. You can see that dark line in there. That's what the crap is. It's starting to drip. See? Drip. 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 We're just going to keep distilling this until it's done distilling or it blows up. As you can see, I got some more stuff, watch. But I'm starting to get scared this is going to get a leak and blow up or something. I mean, not blow up, but catch on fire. So even though I know I'm going to get a terrible yield because of this, I'm just getting too scared. I'm too old. This is a terrible tin can. I mean, it's not like it's made for this. That's my yield. That's a 25 milliliter thingy, so I'm gonna guess that's like 10 milliliters. Well, I don't feel like I have enough liquid to put a Vigorex column in there. I mean, I only got like 10 milliliters. So I'm just going to do a simple distillation, and we'll see what we get. Definitely does smell like toluene, although it smells like benzene also. So it's finally hitting the bulb on the thermometer, and it's not coming over yet. But it's jacked the temperature up to 85 right now. It went right past 80 and nothing came over. So, oh yeah, there is stuff coming over. Just a little bit. So there is some benzene in there. I don't know if you can see it. Here. See how it moves. So there is some benzene in there. It's up to 90 degrees now. So there must not be that much. Yeah, because it just keeps jacking up. So I'll get back to you. Hopefully it'll go straight up to 110 or 11. I'm hoping. I changed the flask out at 105 Celsius. You can see this is a 100 milliliter flask. I mean, what do I got in there? Like 3 milliliters or something. So that's most likely benzene and water. What's coming over right now, that's probably water and toluene. Okay, the benzene's probably out of there by now. So we'll just distill that 105 to as much as we can. There's not much there to whatever, so. Well, that's the end of the distillation. That's a 25 milliliter flask. So I'm guessing that's probably like 3 milliliters. Terrible yield. We're going to have to put some magnesium sulfate in there and dry that up. And you can see how milky it is. So I got some Epsom salt that's dried out. You can see it's milky. I'll throw that in, shake it around. Should clear it up. Yeah, definitely cleared it up. It only took a second. You can't tell on camera, but I don't know if we could. Can't really tell because the light's going off the round bottom thing, but it is totally clear now. So you can see it's totally clear, crystal clear. Although there's only 2 milliliters there. It definitely smells like toluene. It smelled a little bit like benzene before I put the magnesium sulfate in there to dry it up. But now I can't even smell the benzene. No, maybe a little bit. So it is mostly toluene. There is some benzene in there though. Since benzene is pretty unreactive, you probably, unless you're adding something to a ring, you can just leave that in there. It won't react. Most likely with most reactions. That's what I left in the pot. There's a couple boiling stones in there. As you can see, I can't, there might have been a little bit more in there, but I can't break my glass. Alright, so let's see what we got here. Here's our equation, right? Here's our molar masses, right? I used 1/10 of a mole here, alright? Although I did add in a little bit more, because I just added in whatever I had. I think I had 16 grams. But I figured it wasn't pure anyway. You saw it was yellow, you know what I mean? It wasn't pure. So let's just say I used 1/10 of a gram. I was going to use 2/10 of a gram here and 2/10 of a gram here. I wanted to double what I had, right? I don't want to have exact ratios, and I want excess of this stuff so it actually reacts with this. So that came out to here, 8 grams. I should have used 9, or that was the plan, because 1 gram of it was probably water, right, that it soaked up. 2/10 of this would be 11.2 grams. Now, I used, what did I use? Let me look here. I used 16 grams here, which is 7 grams extra. And I used 16 grams here, which is 5 grams extra. And here I used 22 grams, which is like double. The reason why is because it can't hurt to put excess in, you know what I mean? And the amount I had of this compared to the other thing didn't seem like it was enough, you know what I mean, like to cover all of the toluic acid. So I whatever dumped on the scale, and that's what I used. Okay. Now if I use 10% of a mole here, my yield should be 10% of a mole here for my toluene. Here's the molar mass, here's the density, divide them to get the molar volume, and 1/10 of that is 10.6. That's my theoretical yield. I should get 10.6 milliliters. I got 2.4 milliliters, okay? So I divide 2.4 divided by 10.6, I get 0.23. That's 23%. So I got a 23% yield. Now that is a terrible yield for this type of reaction. But keep in mind, I had such a small amount that when you do small amounts, you're going to lose, you know what I mean? Put it this way, if you have a liter or something and you're making it, and you lose a milliliter, are you even going to notice that milliliter? No. But if you're trying to make 10 milliliters and you lose a milliliter, it's going to show up. That's 1/10 of your product right there. You know what I'm saying? I should have got at least a 70% yield on this. And another thing is the toluic acid wasn't pure. I didn't recrystallize it to see exactly how pure it was. Next time, maybe I'll do that. I'll recrystallize it and do this with recrystallized stuff. I just had so little, and the toluic acid I had, half of it I dropped on the floor. So I think I had like 25 grams or something. I dropped it on the floor, and I ended up picking up 16 grams, I guess. But this does prove that the 5-part video I did on how to make toluic acid, it does work. Keep in mind, that's the first time I ever heard of that reaction. Somebody told me about it. So it's not like, you practice with the reaction, you're going to get better. You know what I mean? Because these are terrible yields, I admit. But for the first time I'm doing them, you know what I mean? It isn't bad. I mean, this one here, it all has to do with this. The toluic acid wasn't that great. And the fact that I was doing such a small amount. I mean, like the round bottom flask over here. I don't know if that's on camera or not. I can't see the screen. But, there could be some in there too, another milliliter. You know what I mean? But anyways, it's good science, whether it was a good yield or not. I'm very happy that it turned out that I got a 23% yield. Seriously. I wasn't even expecting that. I was thinking like 10% or something. So I'm happy I got that. And next time, hopefully I'll do a lot better. Anyways, you all remember, science is great, and you have a great day.